So consider light or sunlight in particular entering into a dark room through a very small hole. Now if the light travels in a straight line, you would just expect a small bright spot. But instead of small bright spot, we always see that the light kind of diffracts to various corners of the room, even though it is coming through a single pinhole. So that is a confirmation that light has a waveform, and this principle is called diffraction. In this lecture, we are going to in particular talk about Fraunhofer diffraction. So we will say that there are rays, they are passing through a narrow slit, and these rays are parallel to each other. Now this diffraction occurs when the waves pass through small openings, obstacles, or bend around sharp objects. So you divide the slit into two n parts. We are saying two n parts because there are large number of rays passing through. So for our specific case, we'll take n as 1, and we are going to talk about 2 rays. So 2n becomes 2, so we are going to talk about 2 rays. So you have 2 rays, you have ray 1 and you have ray 2. So the distance between ray 1 and ray 2 is, say, a by 2, and the angle, this angle is theta if this is 90 degrees. So then you can see this difference delta. So delta is equal to a by 2 sine theta, or you can say sine theta is equal to opposite side over hypotenuse, and the opposite side is delta, hypotenuse is a by 2. This also gives you delta as a by 2 sine theta. Now for 2n rays, or dividing the open slit into 2n parts, so instead of a by 2 you can write a by 2n, so because then these rays will become very close to each other. So you can say there is destructive interference when this condition is held. So this is destructive interference. So this is called destructive interference when you have a by 2n sine theta is equal to lambda by 2. Now why is this so? So say this is sine theta in blue, and this is our wavelength right here. Lambda goes from here all the way to here. Now if you shift it by lambda by 2, if there is shifting by lambda by 2, that is the path difference is lambda by 2. So this delta, if this delta becomes equal to lambda by 2, so this is equal to delta, this delta becomes lambda by 2, or delta is equal to a by 2n sine theta for 2n rays. Then we are expecting the ray 1, so this might be ray 1, and this is ray 2. So it is traveling after lambda by 2 distance. Now if you add these two rays, you can see these red and blue ray are opposite to each other. So this is positive, this is negative, you have 0 here. This is now blue is positive, red is negative, you have 0 here. Red is positive, blue is negative, you have 0 here. So these two rays are cancelling each other out. So you have destructive interference here. So you have destructive interference right here, and that is what we will see. You will have destructive interference at these points. So basically when the light falls on the object, you will see a fringe pattern like this. You have a big white patch in front of the narrow slit, and there are small patches right next to it. So there is smaller and smaller. So the light intensity is the highest in the center. So there is light intensity here, then there's a dark patch right here, then again there is light here, then a dark patch here. So notice this is dark patch, then there is light here. So similarly this is below, so the destructive interference here, so there's a dark patch here, there is a light here, there's a dark patch here, and there is a light here. So this is how you can have the diffraction.